Hello everyone, welcome back to the channel. So today in this video we are going to solve the LeetCode problem. Integer in this problem we are going to solve how we can convert an integer to the Roman number. So as we can see that in the problem we have seven different symbols representing the numericals. We have to convert the numerical value into a Roman related number. So as we can see that different examples for this problem. So let's see how we can solve this problem. So let's understand what exactly Roman numericals are. Roman numericals have some predefined values. So as we can see that in the right side part of the code, I already defined the values dictionary with related value and its symbol. Everything was stored within that list, and I also had defined one result string. It can captures the symbol, like it will capture the output of the Roman number. The main idea is simple here. Always we have to pick the largest Roman value that is less than or equivalent to the current numerical number, and append its symbol to the answer. Here answer is RES. We have to append it to the result and subtract the value from the number. Repeat this process until the value becomes 0. That's what we have trying. Now let's walk through the coding part. As we can see that in the code, um, here we defined some values with predefined value with a related Roman symbol, and we are storing the result in a empty string named res, and now we have to iterate through the every value and symbol. If we found the numerical value is greater than the current, like if the current number is greater than the value that we had iterating, we have to append that symbol into the result, and we have to subtract the value from the given input number. That's how we can solve this problem, and finally we have to return the result. Yeah, let's try with a try run how exactly we can be able to solve this. Let's say, for example, if we have number 1994, let's see how we can try run this problem. Initially, we have at initial stage we have number. This is the input that we are going to give for our into Roman function, and the result is empty string. In the first iteration, the number that we are seeing the it is greater than, like for example, if we can see 1994, which is greater than the number 1000 So what we have to do is append the result with m, and we have to minus 1000. We have to do 1994 minus 1000. Then now it would become 994. as we can see that um, and the next value is we are minusing the 900. The corresponding symbol for this is cm. Now append the cm to the current resulted string. Now it would become mcm. Now the number will becomes as 94 after removing the value 900 from 994. The next one we cannot use 94. 94 is smaller, so we can directly jump to the sorry. The next value we are going to see is 90. This is the value of 90. So we are appending the value into the current result. So it will now it would become MCM XC, and finally the number will reach us to the 4 after subtracting the 90 from 94. Now the value of result will become 4. Now skip everything, and now we got the 4. As we can directly see that it is for 4 corresponding symbol is this one, and append the result into the string. Now the result will becomes as like this: MCM XC IV. Now finally the number will reaches to the value 0. After the number becomes 0, we have to finally return the result to the output. That's how we can solve this problem. That is the dry run. Let's see as we can able to run this problem or not. Now I am running here. Okay. As we can see that it is we had already run the program. Yeah, that's how we can be able to solve this. And the time complexity for this is big OH of 1, and the time complexity is also very efficient. And yeah, I'm concluding this problem with simple. Yeah, the key idea is simple. Always choose the largest Roman numerical number, add it to the answer, and subtract it value. As we can see that we have to add the numerical symbol. Sorry, we have to add the symbol and then remove the numerical symbol value from the current number until it reaches to the 0. Here we are implementing the greedy algorithm for this problem, because at every step we make the best possible choice. Yeah, thanks for watching. If you like this video, you can like, share, and subscribe. Yeah, see you in the next video.